Good morning, my fellow classmates. My name is Alfredo Lares. I'm a mechanical engineering student at the University of Texas, but I go to the Houston campus. I want to talk about my first project for system dynamics and control for Professor and Dr. Hassan at 5 p.m. I want to talk a heatsink in which automatically cool itself in PC units and servers. So what is the problem, right? Well, as you guys know, in PC units and in servers, they have many thermal problems, vibration, and if these servers last a lot, then it could cause major breakdowns in the future. So basically, I want to go more in depth to talk about that subject because it's really important. Because when servers goes to production, one of the major problems that servers encounter is that the components that are inside of the server must be thermally tested to see if they can be supported, especially for solid-state drive and processors. The server's mechanical hardware must be able to function at the range of ambient temperature. By providing thermal tests provides the necessary data to determine whether or not components will be able to function inside the server chassis at the highest performance. And that's where this class comes in handy, because this class doesn't only teach us how to solve problems, but this class teaches about solving real life problems. For example, this class teaches about modeling mechanical systems and understanding their response to control inputs and disturbances, such as vibration problems. This will include the derivation of differential equations and use of frequency domain, such as Laplace transform, as many homework as we do, every homework have a Laplace transform, for solution and analysis. As we go along in the PowerPoint, we will find that there are a lot of heatsinks that are out in the market. So these are the one of the metal heatsinks, the liquid cooling heatsink, and the normal fan pulling air heatsink. Many of them are good, but many of them are lacking still performance, cooling performance. So the focus of the project is to create a heatsink with enough work, energy, and power for a better performance inside of a PC or server. By doing that, I will do testing based on transient response analysis with MATLAB in the upcoming days. So this is so far the prototype that I created in AutoCAD, and I'm gonna create it too in SolidWorks or Inventor so I can see a 3D view. So the main objective for this prototype is that um, that I would say that one of my main objectives was to create a system that easily sinks the heat of the server during the cooling of the processor. I realized I had to make use of plurality of server modules. The system needed to include three cooling subsystems. That is the first cooling subsystem for circulating a first cooling medium through the first cooling system, which are the 7 long tall dash, as you guys can see in the PowerPoint. The second cooling subsystem is sought to remove heat from the first cooling subsystem, which are 5 shorter dash. The second cooling subsystem should include a second plurality of conduits for circulating a second cooling medium. Below, or as you guys can see in the front, is a prototype that I implemented to the unit to test airflow and data analysis with MATLAB. This will conclude my presentation for the project that I'm still working on. And I just want to say that for some reason I wanted to record myself talking, but I could not do it because I'm trying to actually show you guys the PowerPoint and to put the camera and to put and to put the mic, I cannot do the same thing at the same time. Thank you so much for listening.